In this video, we're going to be working with page 11 of the Earth Science Reference Table. So let's go ahead and take a look at this graph. If you look at the title, it's Earthquake, P wave, and S wave travel time. And there are two curves on the graph. One of them represents S waves and one represents P waves. So really, to be able to understand how this graph works, we need to understand a little bit about S waves and P waves first. So in general, S waves and P waves are seismic waves, and those are waves that originate from the epicenter of an earthquake. P waves are primary waves. They arrive at the seismic station first, and they travel through both solids and liquids. S waves are secondary waves. They arrive at this station second, and they only travel through solids. So if we take a look and break down this graph, we're first going to look at the vertical axis. And we notice that this represents time in minutes. And if we enlarge a small section, we see that between each minute, we notice there are 3 segments. So if there are 60 seconds in a minute, each one of those segments must be how many seconds? So let's think about this. From here to here is 60 seconds. So if we have 1, 2, 3 jumps, we divide 60 by 3, and we know that each segment is then 20 seconds. So knowing that, what would this time right here be? Well, it would be 2 minutes and 20 seconds because each segment is 20. So 2 minutes and 20 seconds. So let's take a look now at the horizontal axis. This represents distance in thousands of kilometers. Now, it's not written out that way. We see just 5, 6, 7. But if we look here, it says times 10 to the third, which means that we are going to place 3 zeros after each of these numbers. So this is really 5,000, 6,000, 7,000. So let's enlarge a small section. So if this is 1,000, like we just said, and this is 2,000, what are each of these little segments worth? So let's do the same thing that we did. We know we need to get to 2,000 here. So if we count these jumps, 1, 2, 3, 4, 5, that means we need to divide 1,000 by 5. So we know that each segment then is worth 200. So this first line is 1,200, 1,400, 1,600, 1,800 kilometers. So what would this distance be right here? So if this is 5,000 and we're counting by 200s, that's 5,200, 5,400 kilometers. Now this chart can be used to answer many different types of questions. So we're going to start with just a few simple examples. How long does it take an S wave to travel 5,000 kilometers? So we need to go back to the chart and 5,000 kilometers. So we want to start at the distance side, right? And there are 2 curves here. So we want to make sure that we are going up to the S wave curve and kind of ignoring the P wave curve at this point because it's asking about an S wave. So if the distance is 5,000 kilometers, I follow the 5,000 up until I hit the S wave. And then I read over. And so the time it takes an S wave to travel 5,000 kilometers is 15 minutes. Let's try another one. The recording station tells us it took 6 minutes and 20 seconds for a P wave to reach them. How far away from the epicenter of the earthquake must they be? So back to the chart we go. Now this time it's given us a time. So we want to start at the time side, and it's asking us about a P wave. So we're going to ignore the S wave curve, and we're going to make sure we follow it over until we hit the P wave line. So we're going to start here, because that's the time that they gave us. We're going to read over until we hit the P wave line, and then we're going to read down. And so the distance that the P wave traveled in that amount of time is 3,500 kilometers. Now it's time to practice.